Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at an introduction to routing. We'll be discussing router packet forwarding decisions, IP router table, static routing, dynamic routing, and then finally we're going to have an introduction to the IPv4 routing table. This episode is part of my series on Introduction to Networks for the Cisco Certified Networking Associate, also known as the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. When a router gets a packet in, it needs to make a decision on how it's going to forward it on to get towards its destination. Now, it might not be the final destination when it forwards it on. It may be just getting it closer to its destination. Here in this example, PC1 sends out an email. This email goes down through the OSI model, comes across the wire, sent across the local network, and is received right here on R1. It comes into this port. It pulls the bits off the wire, off the physical one. Layer 2 gets all that information, strips off the header and trailer of layer 2, and then we look at the IP address. The IP address, the destination for this is this address. Well, the router 1 routing table knows that if we want to get to this network, which is our destination address, we have to go to router 2. And so what it does is it re-encapsulates it, puts the layer 2 information, puts the MAC address as the destination of this port right here, sends it here, and that's how it forwards it on. Once again, the router strips off the layer 2, the MAC addresses, looks at the IP addresses, looks at the routing table, and then it says, okay, now in order to get to the next destination, I have to send it this direction, either out a certain port, which would be here gig 001, or I have to send it to this device, which is R2. And that may or may not get it to its destination, but it's definitely going to get it closer because that's what the routing protocol has figured out. As we look at the router routing tables, there's 3 types of routes here in the router's routing table. The first one is directly connected. What that means is the networks that are directly connected. If we look at R1 right here, R1 has 2 networks that are directly connected. It's this network here, yellow circle. So this 192.168.10.0 network, that is directly connected. And also this second yellow circle right here, this 209.165.200.224 network is directly connected. So router 1 has 2 directly connected networks. Remote networks. Now, they can either be learned dynamically or you can enter them in manually. But looking at this diagram right here, this is a remote network, this blue one. Now, what we mean is router 1 knows about that blue network, but it's not directly connected. If router 1 knows about the blue network, so it knows about this network, but it's not directly connected, we call that a remote network. And typically, routers know about the networks that are directly connected, and then they find out through routing protocols what these remote networks are. And then the last one down here is the default route. If router 1 gets in a packet and it doesn't know where to send it, we set up a default route. And what happens here in a common scenario is router 1 would then send that information to R2 because of the default route, and then most likely it would go out to the internet. Now, we don't want to keep a record of every device out on the internet, so we set up this default route to handle it. If we don't know of it as a directly connected network or a remote network that we've learned about through one of our routing protocols, then we send it to the default route, which typically leads to the internet at that point in time. As we look at routing this information, one of the ways we can do it is use static routing. meaning you as the administrator set up a special route. Anytime we identify traffic to go to a certain network, it will follow this path. And so we look at the command here. IP route sets up our static route. Anything that matches this remote network. This remote network here, this is the network address, this part right here. So this is the network address. This here is the subnet mask. So it identifies it. And if we look up here, this network is way over here. It's not directly connected. It's a remote network. So this network is here. If we identify traffic that's destined for it, we will send it to this address. This address is the next hop address. And so 209.165.200.226. That's this address. So this is the next hop address. It will send it here. I said next hop. It will send it there. And then router 2, because this network that we're looking for, the 10.1.1.0, because it's directly connected to router 2, it can then properly route it to its destination. The downside of a static route is a static route, you have to go in and you have to enter it. If there's any changes, you have to go in and make those changes manually. In this diagram right here, we have a static route between R1 and R2. And it's forwarding traffic there. It's getting to its destination. And so PC1 wants to send information over here to PC2. It'll use this static route to get here. But let's say a backhoe went through and severed this fiber line right here. It cut this line right here, and now router 1 is no longer able to connect to router 2. There's still a viable path around here, but because you went and set up that manual static route, the data now cannot get across this connection. And so that's one of the downsides of the static route. I hope you are liking this episode on Introduction to Routing. If you had the time, please leave a comment and let me know what you think about Introduction to Routing. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Dynamic routing learns about this through a communication process between the routers on your network. R1 here in this simple little example, R1 is going to let R2 know about the networks that are directly connected. So R1 is going to say, okay, this network is directly connected to me. This network is directly connected to me. It sends that information over to R2. R2 in turn is going to send information to R1 about the networks that are directly connected to it. Over here, it's this network that's directly connected and then this network. And so it's going to pass these two. And the routing protocol is smart enough to identify, hey, this network is in common in between them, so that must be the one that connects up between those. And because of the routing protocol, we now know about all of the networks here in our corporation, in our company. If we take a look at the example before from the static route where the backhoe cut that line, with dynamic routing, now dynamic routing not only keeps track of the best route, it keeps track of all the alternates. And so data is being sent across here from R1 to R2, all of a sudden that backhoe cuts this fiber right here. Once it does that, it no longer can use this best path, but there's an alternate path. And that alternate path then becomes the new best path, and it's able to pass that data through. So dynamic protocol, the ability to change in response to network changes. Still getting you the best route possible. Okay, let's take a look at an example here of a routing table and see some of the parts of that. We have an example here, and what we're looking at here is a network. This network has been set up and functioning, and we're going to start looking at router 1 here. Router 1 has 3 directly connected networks to it. First one here is network 192.168.1.0. Second network is the 192.168.2. Notice they're different networks because that third octet is different. And then the other directly connected network to R1 is the 209 network. So we have three. One of the simple ways starting out, but this will change. If you have 3 lines coming in to the router, there's a good chance you have at least 3 networks there. 3 directly connected networks. So you can kind of use that as a judge. If we want to look at the total amount of networks here, there's also 2 more for R1. There's 2 more remote networks. That's this network here and this network. So there's a total of 5 networks. For R1, there's 3 directly connected, 1, 2, 3, and there's 2 remote networks. R1, we'll call it, and R2. 5 total networks, 3 directly connected, 2 remote networks. Okay, let's take a look at R1. So here we go. I've clicked on R1. We're now in the CLI tab. We're going to go ahead, log in. We went from user exec mode to privilege exec. Once again, changing that greater than sign, typing in enable. That brings us to our privilege exec mode. We're going to enter in the command show IP route. What that's going to do is show us all the information that we know about routing on our router here. Go ahead and enter. This is what we're looking at. As we look here, there's some information. The top part right here, this section right in here, it's labeled by codes. What this is a listing of all these single or multiple letters here on how did we learn about this particular network. Is it a local? Is it connected? Is it static? Did we learn about it about RIP or mobile or BGP? That's what this codes are showing us at this point in time. This here is known as the route source. Underneath the route source here, these are the routing table entries. These are all the networks that my router knows about. So these are all the networks my router knows about right here. I know about a 10 dot network. I know about a 192.168.1, 192.168.1 or .2, 209.165.200 network. I know about 4 different networks for that. As we look here, the letters here correspond to these codes. The letter O right here, if we look up here, that signifies that it was learned through OSPF. That's a routing protocol there that routers use to communicate to determine best paths. Over here, the C. The C is a directly connected network. L stands for local. And you can kind of think of that as the IP address of that interface. This is the directly connected network. If we look here, this is actually a network address here. Whoops. This is a network address, ends in zeros. This is an actual IP address. So that's the local address at that point in time. Then you can see where are these connected. Over here for our 192.168.100. This is connected on our gigabit Ethernet 000. And so where it lists the network, it lists how did we learn about it, what's the network, what's the subnet mask, but then it's also what port is it connected to, how did we get there. Let's look at the entry here for network 10.0.0.1. This was, like we said, this was discovered through OSPF. After the network address here, we can see 2 numbers here. We can see 110/65. First number here is administrative distance, which indicates the trustworthiness or the preference rating for one route or the other. The better the trustworthiness, the more reliable it is. You trust it more at this point in time. The next is a metric, another value used by the router to help determine the path. The metric is calculated by hop count, bandwidth, other factors that all go into this calculation to which is the best path to take towards its destination. So that's what these two numbers are. Then we have the via. And so how do we get to this network from the device we're on? We go to this IP address, which is the IP address of the next router. And so in order to get to this network, you would go to this IP address. The network is directly connected, but this is the IP address on the far side of that connection. Timestamp tells us how long ago the router last received an update. So 39 minutes ago, received the last update. And once again, this is the port on which you go out. Serial 010. That's the port on the router you go out to get to this via IP address to get towards this network. And so there's a lot of information right there in that line. And once again, this is going off of that packet tracer diagram earlier. We talked about how the router had 3 networks, 3 lines going in, 3 directly connected networks, and then there was a far network we knew about. And if we look, there was technically 2 networks because there was a total of 5 networks, 3 directly connected, 2 remote networks. Here is the second network. And so we have all 5 of our networks we know about. And then down here in our routing table, if we look at the last entry, this here is our default static route. If the router doesn't know what to do with it, it's going to send it to this default static route instead of dropping the packet. So that way we won't get any drop packets. Hopefully the router at this destination right here will then be able to route it towards its destination. We won't drop the packet. Here's the same information again. This is displayed as if you'd actually type it on a router itself. You go in there and you type in show IP route, which we did right here. And then we list out all of our data. We have our codes up here, our sources. Then we have our gateway of last resort, which is our static default route. Then we have our remote networks here. At this point in time, in this diagram, we only have 1 network. That's a remote network. And so that's that IP address right there. Then we have 2 directly connected networks to R1. This network right here, and then this network right here. And so that's what this would be looking at. This is the information you can get from looking at these tables. It was my pleasure to provide you with this wonderful episode on Introduction to Routing. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.